How continents undermine oceans. A new theory on volcanic origins, how continents undermine oceans. A new theory on volcanic origins, beneath the seemingly placid surface of our oceans, lie hidden forces shaping the planet's fiery heart. A groundbreaking study reveals a surprising mechanism driving volcanic activity far from traditional tectonic boundaries. Continental fragments being peeled away and swept into the mantle, Earth's sweltering layer beneath the ocean floor. This discovery unravels a long-standing geological puzzle. Why many remote oceanic islands boast distinctly continental elements in their composition, despite residing thousands of kilometers from landmasses. For years, scientists have suspected that these enriched elements, normally abundant on continents, originated from recycled ocean sediments sinking into the mantle or rising plumes of superheated rock, mantle plumes, originating deep within Earth. However, neither explanation entirely accounts for all volcanic islands' unique chemical signatures. Some regions show little evidence of sediment recycling, while others lack the heat and depth needed to be fueled by mantle plumes. The new research, led by the University of Southampton in collaboration with several international institutions, proposes a radical solution. Continents don't just fracture at their surfaces, they also shed material from beneath, stretching over vast distances previously deemed impossible. This process occurs through mantle waves, disturbances triggered deep within Earth when continents start to rift apart. Imagine these waves like seismic ripples spreading out from the continental breakup, traveling incredibly slowly, a millionth the speed of a snail, but relentlessly nudging and dislodging material at depths of 150–200 kilometers. These detached continental fragments are then carried sideways, sometimes exceeding 1,000 kilometers, directly into the oceanic mantle. There, they act as fuel for volcanic eruptions spanning tens of millions of years. Professor Sascha Bruun from GFZ Helmholtz Center in Potsdam aptly describes this phenomenon. The mantle is still feeling the effects of continental breakup long after the continents themselves have separated. This process doesn't simply shut off when a new ocean basin forms. The mantle keeps moving, reorganizing, and transporting enriched material far from its origin. Evidence supporting this theory comes from studying the Indian Ocean Seamount Province, a chain of underwater volcanoes formed after the supercontinent Gondwana split apart around 100 million years ago. By combining simulations with geochemical data analysis, researchers detected a surge in unusually enriched magma erupting soon after Gondwana's breakup. This chemical signature gradually diminished over tens of millions of years as the supply of continental material from below waned, all without any sign of a mantle plume driving the eruptions. Professor Thomas Jernan, lead author of the study at the University of Southampton, emphasizes, while we don't dismiss mantle plumes entirely, this discovery points to a completely new mechanism shaping Earth's mantle composition. Mantle waves can carry continental material deep into the oceanic mantle, leaving behind a chemical fingerprint that endures long after the continents themselves have separated. This groundbreaking research not only clarifies the origins of volcanic activity in seemingly isolated parts of the ocean, but also broadens our understanding of the interconnectedness and dynamic nature of Earth's processes. It highlights how seemingly remote geological events can reverberate through the planet, shaping its surface and influencing its fiery core for millions of years to come.